Great, so let's take a look at section 2.4, which is on solving linear inequalities. Just a reminder of what the four inequality symbols are. We've got less than or equal to, greater than or equal to. So these are both examples of inequalities. Bless you. Okay, one of them on the right, that's more of an inequality that's a conditional inequality. Okay, you have to solve it. This is just an example of an inequality that's a true statement. 3 is less than 8. Okay. So most of the ones we look at today, they're going to have variables in them, and we have to solve it. Okay. Does anybody remember what you have to be careful about with inequalities? We're going to get to it, and I'll write it down, but there's just one thing that's a little different than an equation. Yep.
If it's dividing, I think, by a negative, you have to change the sign.
Yeah, if you divide by a negative, you have to flip the direction of the sign. Anything else? So we have to do that more than just dividing. There's one other operation we have to do. We have to flip the sign if we do this. Yeah? Square root. We'll talk about what would happen if you had inequalities with higher powers, like squared and cubed in them. I'm not sure we're going to get to that today, but it is something we will talk about at some point. But not today. I don't think. We said multiply and divide. So when you multiply or divide both sides by a negative, you have to flip the inequality. Okay, and I'll write that down in a minute. So if I give you a specific value, like say in the equation 3x is greater than 12, and I just want you to check if that number that I gave you is a solution, you just replace the variable with the number and see if you get a true statement. So let's say I wanted you to check when x is 5. Okay, if you plug 5 in, you get 3 times 5 is 15. 15 is greater than 12. Sure, 15 is greater than 12. That's a true statement. That means 5 is a solution. Now, is 5 the only solution? What do you think, Blake? No, right? There's an infinite amount of them. Okay? Usually, when you have an inequality, the solutions are every number from this point greater or less than. Okay, so it's a bunch of numbers that work. Sometimes we have inequalities connected with the word and, okay, like that. This kind of problem you can think of as a between. It says x is greater than -1 and x is less than 3. So it's like I'm saying pick a number between -1 and 3. Okay, so it's between. So a lot of times when you have an and, there's a shorter way to write it, and the way they're going to do it is like that. There's 2 ways you can do it. This is one. I'll show you the other one. But you start with the x in the middle, smaller number on the left, bigger number on the right, and then you have both signs pointing to the left. When you combine 2 separate inequalities into one, these signs have to point the same way. Now, does anyone know the other way you could do it? Still putting an x in the middle? But we mean the same thing? Yeah?
It's just going to be 3 is greater than x, which is greater than -1.
Yep, that's exactly the same thing. And if you look at it and you're like, well, how do you get that? Well, look at this part. X is less than 3. There's your x is less than 3. Now, the second part, a little tricky. X is greater than -1. That's right here. It's not written in the same order, but -1 is less than x. X is greater than -1. Same thing. All right, so you can do the same thing right here. X is greater than -1. That's the green part. And then x is less than 3. There's the red part. Okay, so any questions on how to take an inequality and combine it into a single inequality, or even take a single and split it apart into two. You might have to do something like that on the test, especially if it's a multiple choice answer, and maybe you had it written as an and, but then I wrote it all together. You just have to understand these are the same thing. Even though this bottom one doesn't have the word and, think of it as invisible. It's there, and when you pronounce it, you say it. X is greater than -1, and x is less than 3. You pronounce it exactly the same way as the top one. Just a shorter way to write it. Okay, so this is called an interval from -1 to 3. Okay, and we have different kinds of intervals. There's open intervals, there's closed intervals. This particular interval is called an open interval. And as we've been learning things throughout the year, I've already been using interval notation with you, brackets and parentheses. So this is the first section where they really formally teach that. But since we've already been using like that kind of notation, it shouldn't be that bad. Does anyone have a guess what makes this an open interval versus a closed interval? Yep.
It's not greater than or equal to.
Yeah, it doesn't have the equal to's. Okay, it just has the less thans. Or if you're looking at this other one on the left, the greater thans. So we're going to talk in detail about a few different terms. Open interval, closed interval, and then bounded and unbounded intervals. Okay? Just kind of see what these terms mean. So a bounded interval is an interval where the lower limit and the upper limit is a number. Like if I said pick a number between 1 and 10, what's the lower limit? 1. Upper limit, 10. 1 and 10 are both numbers. Can anybody think of an interval we write where one of the bounds is not a number? Yeah?
Between 1 and infinity.
Exactly. When you throw an infinity symbol in there, now you're talking about an unbounded interval. That's different. So for now, we're just going to stick with bounded intervals. And there's really 4 types. You can have a fully closed interval. To show that an interval is fully closed, that you have the equal to on each end of it, we use the brackets. So if you said to pick a number between 5 and 10, and it was a closed interval, that means I can actually pick the 5, and I can pick the 10. With an open interval, if you put parentheses on it, that means you cannot pick the 5 and 10. So you can pick anything between 5 and 10, but it has to be between. It can't be equal to either one of them. That's an open interval. Half open, or if you're pessimistic, half closed. But half open, you can have it half open on the right, or you can have it half open on the left. Either way. But those are the 4 types of bounded intervals. And just remember, bracket always gets connected to the equal to. Parenthesis is when it's just a less than or greater than. And I think page 99, they actually like sketch out a number line for each one. So if this is A, this is B, they just go like this. And they actually draw it the way it would be on a number line. Okay, so any questions on what a bounded interval is? Or what it means for the bounded interval to be open, closed, or half open? Okay, so let's practice some of these. Actually, we'll do unbounded and then we'll do a practice. So unbounded, okay, that's what Chris just mentioned. That's when it has infinity or negative infinity. Those are the examples you can have of unbounded intervals. If you've got negative infinity, you can either have closed on the right or open on the right. Or if you have positive infinity as one of your bounds, you can have closed on the left open on the left. Now, why did we put a bracket on infinity? Every infinity symbol there always has a parenthesis. Why not a bracket? Yeah.
You can't have something equal to like infinity.
Yeah, infinity is not a number, it's just a concept. It's just an idea of the biggest number that would ever exist, even though it doesn't really exist. So you never can equal infinity. Okay? Always put a parenthesis on infinity. So there's 4 different types. And the difference when you graph one of these, like I'll just graph the top one. Oops. They have arrows. So when you graph these intervals, these are not like a between. Okay? This is like x is less than or equal to 3. That's what that one is saying. This one is saying x is greater than or equal to 5. Okay? So just be comfortable with both ways of writing, actually all 3 ways. X is less than or equal to 3, number line, or the interval notation, which is in black. Okay. If you want to see pictures of all 4 of those, not just the first one, page 100 has pictures of all 4. All right, so let me ask you a question. Could you have an unbounded, fully closed interval? Unbounded, closed. Yep, Robin? No. Because if it's unbounded, it automatically means it's open on one end because you have infinity in there. So you could never have an unbounded, closed interval. Could you have an unbounded, open interval? Unbounded, fully open. Yeah, that's right here. Or here. Could you have an unbounded half open? Yep, unbounded half open. Right there. It's half open, half closed. Okay. Right, so let's try to write an inequality for that. So the way I'd like to do it is to put the x in the middle, if this is the kind of problem that applies to. Tori, what kind of interval is that? Half open. Can you be even more specific? I mean, it's half open on the left. I guess that's more specific. But I'm looking for one other term to describe that interval. It's bounded. So it's a bounded interval, half open on the left. Okay. Anyone think they could tell me, we'll start with putting an x, just pick any variable, but how we could do this. Blake?
X is greater than -3.
X is greater than, like that?
Yeah.
Okay.
And then x is less than or equal to 5.
And x is less than or equal to 5. Okay, so that's our first step. X is greater than -3 and less than or equal to 5. Can anybody combine that into a single inequality for me? Where the word and is like invisible. Yep.
-3 is less than x.
Yep, -3 is less than x. And what do you want? What symbol do you want here?
X.
Less than or equal to 5. Yep. So we got to make sure those inequalities point the same way. Okay. So there's an inequality that represents that interval. So there's nothing there we need to solve. You're just taking something it's like it's already been solved for you. You're just writing the answer a different way. All right, let's try this one. Gabe, what kind of interval is that?
It's half open.
Yep, it's half open and
Bounded. Not unbounded.
it's an unbounded interval, right? There is no upper limit. It goes on forever. There's no bound. It just keeps going. Alright, so Emily, do you think you could help me write that one as an inequality?
Would that be x is that would be less than or equal or less than or equal to or no, it would be greater than
Yeah, greater than or equal to
-4.
-4. And that's it. Some people say, well, don't you have to say and x is less than infinity? No, everything's less than infinity. So that's kind of automatic. So if you put x is less than infinity, you just don't have to. You just write x is greater than or equal to -4. That's it. Right? So the only time you have the conjunction is when it's a bounded interval. When it's unbounded, there's no conjunction. That's actually the simpler inequality. Okay. Right, and let's try this one. How about Natalie? What kind of interval is that?
A closed bounded.
So she said closed. Now, since she said it's fully closed, does she have to even say bounded?
No.
No, because if it's fully closed, that means you can reach each number. And that means they're numbers, right? So it's not wrong to say it's also bounded, but if you say it's fully closed, it's automatically bounded. It's kind of automatic. And Kathleen, could you tell me how we're going to write this as an inequality?
X is greater than or equal to -8,
Okay.
and x is less than or equal to.
All right, so that's a good first step. We've written it as a conjunction, two separate statements. Now let's combine it into one. Kaylee, can you combine that for me into one with the x in the middle?
Does it matter which one you do first?
No, there's two ways. You could tell me -8 or -3, but once you tell me which number you want first, then you have to do it a certain way from there.
-8 is greater than or equal to x. No, less than or equal to
Yeah, well, look at which way it's pointing. It's pointing at the -8, so you got to make sure when you rewrite it, it's pointing at the -8.
Oh, okay. And then does the arrow have to point at the x for the second part too?
Well, it's got to point whichever way it was pointing originally.
Okay, so then it's less than or equal to -8.
Yeah. And when I say which way it was pointing originally, I mean if it's pointing at the -8 to start, when you rewrite it, it's still pointing at the -8. If it's pointing at the x, when you rewrite it, it's still pointing at the x. And that is correct. Okay, the other way that she could have written it would be if you switch the -3 and the -8, and now the signs have to switch as well. Okay? It's pointing at the x. So for the -3, make sure it's pointing at the x. It's pointing at the -8. Make sure it's still pointing at the -8. Both of these are correct. Questions on that? Okay. All right, so let's take and write the answer a third way, which is graphing it on a number line. Let's stick with the bracket and parenthesis. I know we've talked about open and closed circle, but since we're doing bracket parenthesis stuff today, we'll stick with that for our graphing. So Ashley, once I number my number line, what kind of symbol would I put on the 2?
Close.
And which symbol is that if it's closed?
Bracket.
That's the bracket. And since a bracket can face left or right, before I put the bracket, I gotta look at which way I'm gonna shade. Which way are we gonna shade here?
Right.
Yes, we're gonna shade to the right. So bracket, opening to the right, shade to the right. And that's it. Questions on it? So unbounded interval has a ray, arrow that goes in one direction forever without stopping. Another unbounded interval. Justin, what kind of What kind of symbol am I going to need on the 5 this time?
Parentheses.
Yeah, I'm going to need a parenthesis. And which way is the parenthesis going to open?
It's gonna open to the left.
It's going to open to the left. So we're shading everything left. Any questions on that one? So 2 unbounded. Let's do a bounded. Alright, so just number your number line. You can go by 2s if you want, but the numbers aren't too big here, so I think that works fine. Madison, what kind of symbol on -1?
Bracket.
Yep, I agree. Bracket, we're opening which way?
To the right.
Yep, it's going to open to the right because you're shading all values that are greater than -1, greater than or equal. So greater than or equal goes to the right. So we know we're going to end up shading that way, but let's not shade it yet because there's an upper limit on how far we can shade. So Gabe, what kind of symbol on the 3? Parenthesis, and then opening which way? Well, are you shading everything that's greater than 3 or less than 3? Less than 3. So yeah, less than would be to the left. So you're going to shade that way. And now you're shading between. I usually just go like this. Shade between. Any questions on that? Why it's a bracket, parenthesis, or why we shaded between them? Okay. So, it's kind of a lot to say, but if you already know this rule, you don't have to write it down. But if you multiply or divide each side by a negative, you have to flip the direction of the inequality. Other than that, you use all the same steps as if you were solving an equation. Okay, today we're not going to talk about higher order inequalities, like how would you solve, this is a higher order inequality. It's a quadratic inequality. Because that's factorable, that's actually not a bad problem to do at all. It's pretty straightforward once I show you the technique. But I don't think we get into that today. Graphing calculator. Oh, that'll be something more later in the chapter, or maybe even the next chapter. Okay, just remember to multiply and divide each side by a negative. If you multiply and just divide by a negative, flip the inequality. Any question on that rule? Alright, so let's look at an example. And sometimes, depending on how you solve it, what you move side to side, you can avoid having a negative number in front of the variable. Depends on how you solve it. Okay, so let's solve this one. We don't have to graph the solution. We'll just solve it and leave our answer as an inequality, and then we'll write it as an interval. So, Jarek, what would be my first step here?
To distribute the 3 to
Yep.
the x -1.
So we'll distribute the 3. Can you tell me what you get when you do that?
You get 3x minus 3.
3x minus 3. And then everything else stays the same. If you wanted, you could combine the like terms at that step as well. Negative 3 plus 2. It's going to give me -1. All right. What could I do next if I want to try to avoid having to divide by a negative in the end? That's a plus sign, I'm sorry. It's confusing. Good, Chris?
Take 3x away from the 5x.
Yeah, take the 3x away from each side. And then that's nice because 5x minus 3x is positive 2x. You're not going to have to worry about flipping the inequality. What is going to be a little awkward is now the variable is on the right-hand side. Usually we like the variable on the left with an inequality, but we can fix that after. So negative 1 is less than or equal to 2x plus 6 minus the 6. Negative 7 is less than 2x. Or should I have just flipped the sign there? Because I subtracted from each side. No, why not?
You can only do that with multiplication or division.
Yeah, I didn't multiply or divide. I did something with a negative, but it wasn't multiplication. It wasn't multiplication or division. So that's fine. Now divide by 2, divide by 2. Again, dividing by a positive number. Don't flip anything. So you get that. Now, how would we write it so the x is on the left? Because that's how we normally like to write an answer. Yeah, right?
X is greater than or equal to negative 7 over 2.
Perfect. Yep. I like it. I prefer it that way because if you do it that way, the arrow tells you which way to shade. If you don't put the variable on the left, the arrow tells you the opposite way to shade. So that's probably the better way to do it. And that's fine. We actually, you know what, we don't have to write it as an interval. But if we did, would this be bounded or unbounded? Like, unbounded. It's just every single number greater than negative 7/2. It goes on forever. So unbounded. All right, let's look at solving an inequality with the graphing calculator. This comes in handy when you have problems that you can't do algebraically, like this. Right? Unless the numbers work out really nice, I'm just making an inequality. You're probably not going to be able to solve something like that with algebra, but you could definitely solve that on the calculator. So this particular problem is already set up for method 1, which is get 0 on one side. Okay, you don't always have to get 0 on one side, but that is one way to do it. And then calculate a root. Now, this time, the answer is not your root. Your answer is either everything greater than your root, I guess it could be greater than or equal, or it's everything less than your root. All right? So you have to kind of look at the calculator and figure that part out. So get 0 on one side, graph it, calculate the root, and then your answer is either going to be, well, it depends on it. Are you looking for where something is greater than 0? Or are you looking for where something was less than 0? Okay, depending on which one it is, will control, are you picking all numbers greater than your root or less than your root? Look at the graph. So this is one we could definitely do by hand. There's no reason to graph something like this at all. But it's an easy one that we can do graphing, so that's why we'll do it. Okay, what do I have to do first on both sides to use the method I just showed you? Right?
Subtract 2.
Yep, subtract 2. So I'm going to rewrite this as 4x minus 3 is less than 0. So now what we're going to do is type it in on the calculator and put all of that in y1. 4x minus 3. Now you can't do it as an inequality, so we're just going to put it as y equals 4x minus 3. That's fine. But we're going to be looking for where that graph is less than 0. Where is that graph below the y-axis? Okay, so So let's look at it. Oh, it crosses the y-axis right there. Where is it below the y-axis? X values to the left of that dot, or would you plug in X values to the right of that dot? To the left. So our answer is going to be everything below that dot. Everything below it. So second, calc, 0. Pick a point to the left, pick a point to the right, and do your guess. And it comes out to 0.75. So if you plug in any number smaller than 0.75, like if I did 0.5 or 0 or -8, I will always get values that are less than 0. If you plug in numbers bigger than 0.75, like 0.8, 5, 1, okay, any number bigger than 0.75 will give you values greater than 0. That's not what we wanted for this one. Less than 0. So it's all answers less than 0.75. Which, if you add 3 to both sides and then divide by 4, you get x is less than 3/4. Exactly the same way. But again, we'd use the calculator more on problems that we can't do with algebra. Or it would be very, very difficult with algebra. So, any questions on how we got that? X is less than 0.75 on the calculator. All right. So, second method you can use. Don't rewrite it at all. Leave it exactly the way it is. Take what's on one side, put it in y1. Take what's on the other side, put it in y2. And what I'll do is I'll do this in color. Y1 is blue, so let me just change that. So take what's on the left, I'm going to put it in y1. Take what's on the right, put it in y2. Let's just start with that. So now I'm leaving the equation, I'm leaving the inequality exactly the way they gave it to me. Not doing anything.
You did it wrong.
Thank you. That would be a problem. Okay, so now what we're looking for is where the blue graph is less than the red graph. If you want to think about it in terms of the colors. Where is 4x minus 1 under the red graph? So let's look. So here's your blue graph. Here's my red graph. And I want to know where the blue graph is under the red graph. So what do you think I have to calculate here? I'm not going to calculate a root. Yeah?
Intersection.
I'm going to calculate an intersection. Second calc, intersect. Pick a point on the blue, the red, do your guess. It says that they intersect when x is 0.75. So now I just have to ask myself, do I want everything above 0.75 or below? Well, I want to know where the blue is under the red. That happens with x values that are smaller. If you pick bigger x values, the blue graph is way up off the screen. It's way higher than the red. Okay? So x is less than 0.75. So there's two different ways to do exactly the same thing. Get it equal to 0, or get 0 on one side and do a root, or leave it the way it is and just do an intersect. Either way. So we just did that. Find the intersect and then determine if you want the values above or below the intersection value. Okay, so I already did that, so we won't do that. Questions on how to solve an inequality with this method? Okay, use whichever one you want. Hey, double inequality. Okay, let's look at this one. So, double inequality, kind of like what we looked at earlier with a conjunction. But how do we solve that? Well, the goal with a double inequality is to get x by itself, just like the goal always is. Except, you don't just have a left and a right. You have a left, a right, and a middle. So whatever you do to the middle to get x by itself, you have to do it on the left, and you have to do it on the right. So this particular problem, if I was going to have you solve it, that's how you do it. So -4 is less than x, which is less than 6. Same rule applies. If you divide by a negative, you have to flip the inequalities, this time both. But other than that, it's pretty much the same thing, solving a regular inequality. So let's try this one. We have -3 is less than 2x plus 5 divided by 3, which is less than or equal to 5. So the goal eventually is to have that be the only thing in the middle. So you've got to get rid of the 2, the 5, and the 3. Did anyone have a guess which one of those we would get rid of? Yeah?
Multiply by the 3.
Yeah, multiply everything by 3. So I'm just going to do all of that times 3, times 3, times 3. Did I multiply by a negative? No, I don't need to flip anything now. Those 3's are gone. So now I have -9. Does everyone have what's up there? Okay. So -9 is less than 2x plus 5, which is less than or equal to 15. Okay, so that's good. That's my first step. What would I do next, Robin? -5 here, here, here. -14 is less than 2x, which is less than or equal to 10. And my last step, divide by 2, and that's a positive, so nothing you have to flip there. So the answer is all values of x that are greater than -7 and less than or equal to 5. Any questions on them? So that's solving a compound inequality. Okay, absolute value inequality. Okay, did we, trying to remember yesterday, did we look at absolute value equations yesterday? We did that? Okay. So, solving an absolute value inequality is kind of the same thing. First thing you have to do is make sure your absolute value expression is by itself. So what does that mean? You've got something like this. That's an example where the absolute value is by itself. Here's an example where it's not. Now you've got a -6 on the outside. So you could have something like that. You would have to do a +6 to each side. Or if you had something like that, you would have to do a divide by 12 on each side first. Okay, so you've got to make sure the absolute value is by itself. Then once we have that, split it into 2 problems. And this is just like yesterday, except change the word equation to inequality. So the first inequality is exactly the same as the original, just erase the bars. So it would be x plus 2 is less than or equal to 3. The second inequality is the same as the original, except we get rid of the bars. And yesterday we had to make the number on the other side negative. Well, when you make something negative like that with absolute value, remember, or with inequality, you've got to flip the sign. Okay, so that's something that's new that you didn't have to do yesterday. So the second inequality is the same as the original, except you take away the bars and make the number negative, just like yesterday. But the extra step is to flip the sign. So in this case, it would be x plus 2 is greater than or equal to negative 3. That would be my second problem I would solve. So that's the setup, how you get rid of the bars, how you split it into two problems. Well, once we do that, that's great. We can solve it. We can write out the answer. But once you have your answer, you're going to have two inequalities. Okay? One on the left, one on the right. You have to put a word between them. And the word you put between them is one of those two. Now, yesterday we always used the word and. When it was an absolute value, it was x equals 2 and x equals 7. Today you have a choice. Sometimes you use the word and, sometimes you use the word or. How do you tell? Look at the original problem. Once you have the absolute value by itself, look at that problem. Look at that inequality. That's a less than. If I solved this problem, I would have two inequalities, and I would put the word and between them. If the original problem had a greater than or equal to, I would use the word or. And the fancy word, and I think we've seen these symbols before, and is called an intersection. It's kind of like an overlap. If you think of like a Venn diagram, and I said to you, color the section that's in A and B, that's where A and B intersect. So you can think of it that way. A union is just an or. Could be one or the other or both. So if I said shade in what's in A or B versus A and B, well, you could shade in what's in A, or you could shade in what's in B, or both. So what's shaded in black is A or B. All right? So that's where those symbols come from. Okay, but if you can remember and or, that's what I'm going to look for in the final answer. Okay, so let's try this one. So absolute value of x minus 3 is less than 3. Yeah, Blake?
X minus 3 is less than 3.
Is the absolute value already by itself, though? Yeah, it already is. So there's no other numbers on the outside of the bars, on that side. So we're ready to split it. And can you tell me the other one too, Blake?
X minus 3 is greater than A.
Perfect. The only thing I need now is to put the word, and I usually write it right now so I don't forget. Am I going to put the word and or the word or? Yeah. And. Sometimes the way I remember it is if you think the less than symbols, less than begins with an L, land. Less than is always an and. Doesn't matter if it's less than or equal to or just less than. Land. If that helps you, you can go with that. And now the steps are going to be the same to solve each one. Plus 3, plus 3. So x is less than 6. And plus 3, plus 3. X is greater than 0. Okay. Other way you could see this written, 0, 6. Writing it as a combined inequality. So when you have an and, a lot of times you end up shading between. When you have an or, like if I flip this around the other way, or you usually end up shading in opposite directions. So ors usually look something like this. Might have closed circle, and you shade like that, versus an and, could be open or closed circle, but and you usually shade in between. Usually. So any questions on solving an absolute value inequality? Again, something right now I'm teaching in Algebra 1A, so that goes way back. But sometimes it's a little hard to remember, like and or and stuff like that. Does anyone want to see one that is an or? This one would be an or. No, I'm good with that? Okay. I think that's the same. Well, that's actually like we did on the last one. That's an and. All right, let's just try it on the graphic calculator because we haven't done that. All right. So let's put in absolute value of, what is it? 1 minus 2x. So remember, absolute value is a V shape. So you're going to have a line. You're going to have a horizontal line at 4. You're going to have a V shape. And I'm going to want to know where my V shape is less than 4. Now, I had a couple options. I could have done this with method 1 or method 2. I chose method 2. I just thought it was easier to leave what's on the left in y1, what's on the right in y2. But that's up to you. Okay, so there's your absolute value. We're going to have a horizontal line at 4. And the question is, where is the blue graph, the absolute value, below or equal to the red graph? So, what do you think I would have to find first there to figure out where the blue graph is less than or equal to the red graph? Chris?
The intersection point on the left.
Yeah. I don't know what that intersection point is exactly, but let's just call it A, comma 4. I know it's at 4 because that's the line y equals 4. And let's just call this one B, comma 4. So you got to find A and B on the calculator. And then if you want to find all the values where the graph in blue is under the graph in red, would it be all values between A and B or all values outside of A and B? Which way would this one be? Yeah, Chris?
Inside.
Yeah, between them. Yep. And we can include A and B because of that symbol right there. So any value between A and B, if you plug it in, you'll get a point on the blue graph, and it would be below the red graph. If you pick values outside of A and B, bigger than B, you're going to be way up here. That's above the red graph. That's not what they wanted, below. So one we definitely could have done by hand, but that's how you could do it on a calculator. So you got to find 2 intersection points. I think, yep, it's the last one. All right, so directions here to say solve algebraically. Okay. So we're looking for where this fraction is greater than 0. How could a fraction be less than 0? What kind of calculation would you have to do to make a fraction come out less than 0? Yeah.
It would have to be like a negative fraction.
Can you be more specific? Like, what do you mean?
The fraction is like equal and negative decimal to like.
If you divide it out?
Yeah.
So where does the negative have to be if you want to do that? Like in a general fraction, the negative could be where?
Can it be like on either the top or the bottom?
Normally, it could either be on the top or the bottom, yes. How about in this fraction? Yeah? It would have to be in the top if you were going to make that fraction negative. This bottom is always positive, no matter what. We're going to assume that x is never equal to 2, because if you plug in 2, then you're dividing by 0. That's a whole other problem. So, assuming you never use 2 in this problem. To make sure that this fraction always comes out positive, all you have to do is make sure the top comes out positive. That's it. Don't ever worry about the bottom. The bottom is always going to be positive no matter what. You can't make the bottom negative. It's impossible. But the top you could. So all you have to do is make sure the top comes out positive, and I guarantee you the whole fraction will be positive. So it looks a little tricky, but if you reason it out, that's it. So now x would have to be greater than what number? Yep. X is greater than -3. If you pick any value greater than -3, that fraction will be positive. And if you look and you're like, well, wait a minute, if I plug -4 or -2 into the bottom, -2 minus 2 is -4, but then you take an absolute value of it, so it's fine. And that's it. Right, so tomorrow we'll finish up chapter 2, okay? And I think that's probably going to be getting towards the end of some of the more familiar stuff. Chapter 3, we might start getting into some of the stuff you haven't seen before. All right, so the homework just kind of jumps around a little bit. So it's 5 through 7, 10 and 11, and then 14 through 16, 25, 26, 29, 34, 35, 42, 43, 49, and 60 to 62. Okay, some of it's on the graphing calculator, some of it is just solving simple inequalities by hand. But you'll remember the graphing calculator for a few of them.